Hi guys, here we are with a special section. This is all about special right triangles. I love this stuff. I think that this stuff can make things so much quicker and easier. And I hope this is really helpful to you, not only for this class, but especially if you go on and take maybe pre-calculus or calculus. The more you know these special right triangle ratios, or even just like the SAT prep class, the better off you'll be. So with these triangles, we need to know that there are special relationships between each one. I'm going to do a little proof of them and then show you a lot of examples. And I think once you get it down, it's something that's going to be pretty easy for you to figure out. So I'm going to say that, let's just call each of these x. If this is a 45, 45, 90 triangle, what that means is that it's an isosceles triangle where these two angles are both 45 and this one's 90, and you'll have the hypotenuse here. Well, I'm going to set this up in the Pythagorean theorem first. So x squared plus x squared equals the hypotenuse squared. Or if I solve this, I'm going to have 2x squared equals the hypotenuse squared. I can take the square root of each of these, and when I take the square root of this, technically I'm taking the square root of each part. So this is going to be h. This right here, I can take the square root of x and just bring that in front, and this is going to be x times the square root of 2. This will always be the ratio for these. It doesn't matter how they look. If I put some specific numbers in here and do the Pythagorean theorem with these, let's say that I know that this side is 7 and this side is 7, and I want to find the hypotenuse. Well, that's going to be 7 squared plus 7 squared equals the hypotenuse squared. When I add these up, I have 49 plus 49 equals the hypotenuse squared. That's 98 is the hypotenuse squared, and when I take the square root, again, instead of simplifying this, I'm going to rewrite it as the square root of 49 times the square root of 2, which is 7 times the square root of 2. Or let's do one more. Let's say that here I don't have the right angle, or I have the right angle, but I have these marked instead of the angles. Let's say that each of those are 5, and I want to find the hypotenuse. So 5 squared plus 5 squared equals the hypotenuse squared. So 25 and 25. I know I'm going through this fast, it's just more meant to be an illustration. So when you take the square root of each, it can break into 25 times 2. Each and every time it's going to look like this, and each and every time you're going to have whatever that segment length was, and then times the square root of 2. And this is really important because for every single 45, 45, 90 triangle, they will always have this ratio because all of those triangles are going to be similar and their sides are always going to be proportional. Here is the actual theorem that says that. It says the legs, they use L. I used X in that example that I did earlier. They're always going to be congruent, and the length of the hypotenuse is always going to be the square root of 2 times longer than the length of the leg. So if you want some ratios here, I always write it as 1 to 1 to the square root of 2, where these are your two legs, and this is your hypotenuse. And that is only for if it's a 45, 45, 90 triangle. So in this case, you'll love these, I promise. If you get it, they're so easy. For this one here, because both of those are 5, the hypotenuse is just going to be 5 radical 2. For this one here, both of these would be 7 radical 2. So you're just going to have to multiply by the square root of 2. So 7 times the square root of 2 times the square root of 2 is 7 times the square root of 4, which in other words is 7 times 2, and this is going to be 14. You don't need to set up anything fancy. You just need to decide if you're multiplying by the square root of 2 like you did for these. When you have the leg, you're going to multiply by the square root of 2. or if you're going backwards, you're going to have to divide. So when you have the hypotenuse, you're going to have to divide by the square root of 2. So this one here, when you have 5 radical 2, I'm dividing because I'm going back to the leg by the square root of 2. Those are just going to cancel out, and that's going to make each of these 5. It's actually the same problem as that, just kind of a different starting point. The only time it gets a little tricky, and once you do enough of these it won't seem tricky, but here you have to divide by the square root of 2, and you can't leave it like that. So if you remember back to the beginning of the year or to Algebra 1, you can't have the square root in the denominator, so I'm going to multiply each side by the square root of 2 over the square root of 2. So 18 radical 2 over 2. And then sometimes, not all of the time, but sometimes you're going to be able to simplify it, and in this case you can divide those each. So the answer to this is going to be 9 radical 2 for that leg. And you could always go back and multiply by the square root of 2, just like we did here, to check and see that that's in fact 18. Okay, and then for our next example, it's dealing with a 30, 60, 90 triangle. And I'm going to take a equilateral triangle and split that right down the middle at its altitude to illustrate this. So let's say that this was an equilateral triangle and each of these sides were 10. If I'm looking at this half, now this half would be 30, 60, and 90 degrees. And I can find each of these other portions. So since this whole thing is 10, that's going to make this part here 5. And then I can use the Pythagorean theorem to find the height here. So I'd set this up, x squared plus 5 squared equals 10 squared. So x squared plus 25 equals 100. Subtract 25 from each side. So x squared equals 75. Or when you take the square root, this is going to be the square root of 25 times the square root of 3. So 5 times the square root of 3. And the nice thing about this is actually going to work every single time. Doing another little algebra proof here. They have, let's say this is 2x, that's going to make this x, just because that's always going to be half of that side. And then when I set this up to find what a is going to be, that altitude, I'm going to set this up, a squared plus x squared equals, I got to put this part in parentheses because I got to remember to square each part. So a squared plus x squared equals 4x squared. Subtract x squared from each side. So a squared equals 3x squared. Or when you take the square root of each, this altitude or this height here is going to be x times the square root of 3. And this, just like the one that was 45, 45, 90, this will always be the relationship between this side and that side, and this one will always be twice as long. So this is another special ratio that will happen, and you'll see it a lot. So we can go through some examples of this, just so you can kind of see what I'm talking about. So in a 30, 60, 90 triangle, the length of the hypotenuse is 2 times the length of the shorter leg, and then the length of the longer leg is the square root of 3 times the length of the shorter leg. So the way I say that is I say the ratio is 1 to 2 to the square root of 3. And this is the short leg, 2 is the hypotenuse, and the square root of 3 is the long leg. So I'm going to skip this first example right now and do these two, and I'll just kind of show you how you're going to use it. If you're going from a shorter side to a longer side, you multiply, and if you're going from a longer side to a shorter side, you're going to divide. If I don't have the short leg, I always find that one first. So here I have the hypotenuse, and I'm trying to find the short leg. So the relationship between those two is 1 to 2. So in this case, I'm going to have to divide by 2 to get the short leg. So since this one is 10, this one here is 5. Think back to that first example we did a minute ago. I should have probably picked a different number like 8, I'm just realizing. And then the relationship between the short leg and the long leg is 1 to the square root of 3. So here I can just multiply by the square root of 3. So for this one here, it's going to be 5 times the square root of 3. I prefer doing it like this. If you would like to set up proportions, you could always do that also. You could say that the relationship between these two is 1 to 2. You don't know the short leg, and you know the hypotenuse is 10, and then you could cross multiply. Or the relationship between the short leg and the long leg is 1 to the square root of 3, and that would be 5 to y, and then again you could cross multiply. Probably once you have this down you won't have to do that, but if that maybe helps a little bit at the beginning, you could always set up proportions. For this one here, they give you the short leg, so I would just use that. Make sure you pay attention to which one's the hypotenuse and which one's the long leg, so you know what you're multiplying for those. So in this case, doubling this to get to the hypotenuse, that's going to be 42. And then multiplying by the square root of 3, it's not as tricky as it looks because we're leaving in radical form. So you can just write 21 radical 3, and then you're done with this problem. Again, I promise once you have this down, you can go through these problems really quick, and it's just kind of a nice shortcut for you. And if you go on and take some higher math classes, these triangles will show up a lot in different things. Okay, the hardest one for last though, this one here, you really have to pay attention to sometimes whether or not this is the hypotenuse or not. And the hypotenuse is the one that's across from the right angle. So this is the long leg, and it's not quite as nice dividing this one by the square root of 3, because again we can't have radicals in the denominator. So I'm going to multiply this by the square root of 3 over the square root of 3. It's going to be 12 radical 3 over 3, and then sometimes you can't simplify it. In this case we can, but sometimes it might just be written like this, where you might have like 10 radical 3 over 3, and that's just your final answer. But in this case here I can simplify it because I can divide 3 out from 12. So x is going to be 4 radical 3 after I divide there, and then I'm going to multiply by 2. So that's going to make this one 8 times the square root of 3. So again, once we practice and once you get the hang of it, I hope you enjoy this as much as I do, and I will be definitely around to help you guys in class.